We saw one of our cases for the worksheet, our number C in the last question, that we didn't have just one solution. Sometimes we get what is no solution or infinite solutions in solving an equation. Sometimes equation has either no solution or multiple solutions. So what we had before, so when we had one solution, we have 1, 2, 3 solutions, but it's a countable number of solutions. We say that's finite. So for the most part, because we're dealing with linear equations, we just have to deal with this case where we just have one solution, so that's a finite solution. So we have what we call consistent, inconsistent, or a contradiction, or an identity when we're trying to talk about what kind of solutions we can have and what kind of equations we have. An equation is called consistent if there is at least one solution. So if I have a solution, it's consistent. It's inconsistent or contradiction if the equation has no solution. So that's one way we define equations. Either they have solutions and they're consistent, or they have no solutions and they're not consistent. Then the second part of this is identity. An equation is an identity if it is true for all numbers in the domain. And in our case, that's just going to be for all real numbers. So what we have here is that if we're consistent, but not an identity, that means that we should just have one solution. If we're inconsistent, we have no solution. And then if we're an identity is going to be still consistent, but we're going to have infinite solutions. We're just going to decide what solutions that we're going to have here and what kind of equation that we have. So if I solve this one, I have 3x minus 7 equals 3 times x plus 1. So left side, don't have to simplify. The right side, I just need to do this distribution. Anyways, I get 3x plus 3. So when you have the same variable with the same coefficient, right there, that is going to be a hint that either we're going to have no solution or infinite solutions. So this one, you're going to see it's going to be no solution. And what's going to happen is we have that 3x on both sides, so I'm going to deal with the constant first. So let's say we add 7 to get the constant alone. That's going to give me 3x is equal to 3x plus 10. Now, if I try to deal with that 3x, because I don't want 3x, I want this 10 by itself, I want constants all alone on one side. What's going to happen is that cancels, and I'm just left with 0 here. But I'm still left with 10 here. 0 cannot equal 10. My thing's doing something weird on my end. There we go. So when you have something like this, you have an inequality. The inequality tells me that this is an inconsistent equation. It also tells me that I have no solutions. Because 0 is equal to 10, that cannot possibly happen. Since I have a situation that cannot happen, that means there's no solution that's going to rectify this. There's nothing I can put in for x up here that's going to make both sides equal. So if you look here, if I say x is 1, well, then you're just going to have -4 on one side and you're going to have 6 on the other. If I say x is 0, I have -3 is equal to -7 is equal to 3. If there's nothing I can pick, it's going to make both sides equal. So when you have an inequality at the end when you're trying to solve the equation, that means you have an inconsistent equation and you have no solutions. So since no value for the x can be substituted in the equation that would make this a true statement, we say there's no solution. One of the ways that we write no solution is we write our set brackets, but we put nothing in it, or we write the sign. This both means an empty set. So in this case, we're going to see something a little different. This is going to be more like what we saw earlier when we were working on those worksheet problems. Once again, left side's fine. I don't have to simplify. It's just the right side. I'm going to distribute this 2. And I have 2x plus 2 is equal to 3x minus 7. Then we're going to put like terms together. So I have an x and an x. That's going to be a 5x. I have a constant and a constant. That's going to be a -5. So we see as both sides right here are equal. So right there, that's going to be a hint that we have infinite solutions, but we're going to just keep going with this. Usually what we do is we just try to keep going. So if I try to get rid of this 5, I'm going to take that 5 with it. Once again, both sides are equal. But, we're going to go a little further. We're going to try to like isolate it on both sides. So we subtract that 5x. We get 0 equals 0. So usually it's 0 equals 0 is what we use. But really what it is if both sides are equal, if we had in all 3 of these situations, if you end up in a case where both sides are equal, that means that we are going to be an identity. And this also means we're going to have, or the equation's an identity. It is consistent and it's an identity. And what that means from there is that we are going to have infinite solutions. Or sometimes we say the solution is all real numbers. So 3 things that can happen is you're going to have just solution. You'll have infinite or no solution or infinite solutions. So both sides are identical. Since this means this equation is going to be true for any x that we pick. So like right here at 5x minus 5 equals 5x minus 5. No matter what x is, both sides are going to be equal. So no matter what we substitute for x, it's always going to be equal. So our solution is all real numbers. So take a moment on your worksheet and work on A and B. One of these will hopefully be constant, and one will hopefully have no solution. One will hopefully have infinite solutions. Just give me a chance to identify that. So if I distribute, we're on A here. So first thing I'm going to do is simplify both sides. I'm going to distribute that 3. I get 3x minus 6 equals 5. I'm going to distribute this invisible -1 over here across, and we end up with 4x minus 1 minus x. Combine like terms, I'm going to have on the right side, or sorry, the left side, 3x minus 1. And on the right side, we have 4x minus x. So we have 3x minus 1. So that should be more than enough. We see that both sides are equal, but let's say we just keep going. Add the 1, 3x is equal to 3x. So we subtract 3x because we're trying to isolate those x's to one side, and we get 0 equals 0. That means that A has infinite solutions. Or we can say the solution is all real numbers. Now if we do B, I'm going to do this a little funky. We'll write B down here. So B, I have 5x minus 6 is equal to 5 times x minus 1 plus 3. So we have 5x minus 6 is going to be equal, if I distribute the 5, to 5x minus 5 plus 3. That means 5x minus 6 is equal to 5x minus, lost my place there for a second. So we're seeing we both have a 5x, but different constants. That right there is a sign that we're going to have no solution. Well, let's keep going. We add the 6, see what's going to happen here. And we get that 5x is equal to 5x plus 4. We're going to subtract that 5x because we're going to try to isolate our constant. And we're going to end up with 0 on this side because everything's disappeared, and 4 here, which is not equal to each other. So for B, this is inconsistent. Remember, we write inconsistent, so it's just legible. Inconsistent and has no solutions. If I were to write the solution set for this one, I would either write just empty set brackets, or I'd write that a symbol for an empty set, or sometimes we call that a null set.